Hello children, welcome you all to the second part of our chemistry chapter Physical and Chemical Changes. In previous video we have seen physical changes, and in this video we will be doing some activities related to chemical changes. So let's get started. To understand chemical changes, let us perform some activities. Activity 4. Aim to observe a chemical change with iron nails. Materials required: few shiny iron nails and a plate. Procedure: take a few shiny iron nails in a plate. Place this plate in any moist place out of your house. Observe them after a few days. Not your observation. I hope you all can do this activity at your home. Observation: a brown layer is formed on iron nails. And after this activity you will observe that a brownish layer like this will be formed on the article or iron nail which you are using will be seen. Conclusion: the shiny iron nails get rusted. We cannot get back the shiny iron nails from rusted ones, which makes it irreversible change. Thus, rusting of iron is a chemical change. So, you all know that this is an irreversible change. Moreover, a new substance, that is a reddish brown coating, is formed, which makes it a chemical change. Okay children, let's proceed to activity 5. Aim to show that burning of a magnesium ribbon is a chemical change. Materials required: a magnesium ribbon, a sandpaper. The sandpaper is used to clean the magnesium ribbon for proper burning, as magnesium ribbon has some coating of magnesium oxide on it. So the sandpaper is used to remove that coating. A pair of tongs, a burner, a test tube, a dropper, and a blue and red litmus paper. Procedure: take a magnesium ribbon and clean it with a sandpaper. Observe its color. Hold it with a pair of tongs and heat it on a burner. You will be seeing the observation very soon in a video. Note your observation. Let the magnesium ribbon burn completely. Now collect the substance formed and observe its color. Can you change the ash formed back into magnesium ribbon? Do you think a new substance has been formed by burning a magnesium ribbon? Now take a test tube and put the powdery ash in it. Add little water to the test tube and shake well. Put a drop of this solution on the blue and red litmus paper. Note the color change, if any. So here what we are doing, we have taken magnesium ribbon whose formula is Mg. That is magnesium ribbon. Burning it means we are reacting it with oxygen gas. As the reaction proceeds, you will get magnesium oxide. The formula of magnesium oxide is MgO. This is in the form of ash, which is a white powdered solid. Now we have to take this ash and we have to put it in water, which we have taken in test tube. As you all have not read acids and bases, so I am just telling you what we need to do. We'll add this in water and then we'll take litmus paper. What is litmus paper? Let's see. Actually, litmus paper tells you whether a solution is acidic or basic. In this section, all you have to remember is, if you take a solution and you put a litmus paper in it, if it turns red, it is acidic in nature. If it turns blue, it is basic in nature. So all you need to know right now is this much. So we'll just check whether this magnesium hydroxide is acidic or basic in nature. So let's proceed Observation. Magnesium ribbon burns with a dazzling white flame. It's a very brilliant white flame. On burning completely, it forms a powdery ash. The powdery ash so formed is not the same as magnesium ribbon. So you know a new substance is formed here which makes it a chemical change. Conclusion. The powdery ash is magnesium oxide. A change has occurred on burning a magnesium ribbon, which can be represented as when you take magnesium and react it with oxygen gas, that is burning, you will get magnesium oxide. On mixing magnesium oxide with water, a new substance, magnesium hydroxide, is formed. The formula for magnesium hydroxide is MgOH whole twice is formed. This is represented as follows. So when you react this magnesium oxide with water, magnesium hydroxide will form. This section of the reaction or this activity belongs to acids and bases and salts. So after reading that chapter, you will be more confident about this topic. Okay, let's proceed. Magnesium hydroxide is basic as it turns red litmus blue. So as it is turning red litmus into blue, it indicates that magnesium hydroxide is basic in nature. Thus, burning of magnesium ribbon is a chemical change. Precaution, that is, cautions to be taken care of while performing this experiment. Do not look at the burning magnesium ribbon for long. It may harm your eyes. Now let's see a video related to this activity. Here we'll see burning of magnesium ribbon. This strip is magnesium ribbon. With a pair of tongs, we will hold this magnesium ribbon and try to burn it. Please observe how magnesium ribbon burns. Can you see how magnesium ribbon burns with a dazzling white flame? Now we'll collect the new substance formed in the watch glass. This new substance formed is magnesium oxide, which is a powdery substance. Children, let's now see our sixth activity. Aim: to observe a chemical change with zinc granule and dilute hydrochloric acid. The formula for zinc granule will be Zn, where capital Z will be there and small n. And the formula for dilute hydrochloric acid will be capital HCl. Materials required: a clean zinc granule, a test tube, a dropper, dilute hydrochloric acid, a matchbox and a candle. Procedure: place a clean zinc granule in a test tube. Touch the bottom of the test tube. Does it feel warm? With the help of a dropper, add some dilute hydrochloric acid to the test tube. Observe the changes taking place. Bring a burning candle or a matchstick near to the mouth of test tube. Note the observation. Now touch the bottom of the test tube. Does it feel warm now? Observation: on adding diluted hydrochloric acid to the zinc granule, bubbles of a gas are seen coming out. On bringing a burning matchstick near to the mouth of the test tube, a pop sound is heard and the bottom of the test tube is felt warm. Conclusion: when zinc reacts with dilute hydrochloric acid, two new substances named zinc chloride, which remains soluble in the solution, and hydrogen gas, which is indicated by a pop sound, are formed. During the reaction, heat energy is released. This change can be represented as follows. Zinc, when reacts with hydrochloric acid, it gives zinc chloride and hydrogen gas. Here, the hydrogen from hydrochloric acid will form hydrogen gas, whereas zinc will react with chlorine gas. We can represent it with the help of symbol also. Zinc, when it reacts with hydrochloric acid, you will get the zinc and chlorine will combine together and form zinc chloride, and you will get hydrogen gas. This change is irreversible, thus the change taking place when zinc come in contact with dilute hydrochloric acid is a chemical change. Let's perform another activity. Take a clean test tube and pour 3 ml of concentrated hydrochloric acid in it. Now we'll take a piece of zinc granule I hope you all can see how it looks. It's a silvery metal. We'll pour this metal in the test tube and please observe what happens. Can you see the release of bubbles? Now we'll put an inverted test tube above it to collect the gas released in this reaction. The reaction taking place here is zinc when reacts with hydrochloric acid, it produces zinc chloride and hydrogen gas. Now we have to test the presence of hydrogen chloride. As you touch this test tube, you will see that it is hot. As it gives off energy or heat, it is called as exothermic reaction. To check hydrogen gas, when you bring a burning matchstick near to it, it will burn with a pop sound. So now we will check that. We'll bring a burning matchstick
on fire.
Did you heard the pop sound? It confirms the production of hydrogen gas. Children, let's proceed with the question answers to be written in the notebook, and we come to question number 3. Name a metal which burns with a dazzling white flame. I hope you all know the answer to this question, and the answer is magnesium metal. Question number 4. Is magnesium hydroxide acidic or basic in nature? Why? Answer to this question is magnesium hydroxide is basic in nature as it turns red litmus to blue. You will read more about acids and bases in the chapter Acids, Bases and Salt. Question number 5. Tina saw that the volume of perfume in her bottle had become less after a few days. Is it a physical change or a chemical change? As you all know, it is a physical change, as no new substance is formed here, and moreover, the liquid here changes to gaseous state. Children, kindly note down these questions in the notebook from the PDF provided to you. I hope you all enjoyed the video, so keep smiling and keep studying. Have a wonderful day.